Welcome. Today we are going to discuss the JEE mains paper which took place on 9th of January morning shift. Okay. What we are going to do is we are going to do a quick analysis of the different topics that came in that paper, and we are going to solve a few problems on it. So there were a total of 30 questions, and out of that 13 were from electromagnetism. So you can see that a good percentage, above 40% of questions were from electromagnetism. And then around 8 questions were from mechanics, 2 were from modern physics, 3 were from optics, 1 was from SHM and waves, and about 3 questions were from thermodynamics. Okay. So because electromagnetism bore the highest percentage, let's solve a problem from electromagnetism. So here I have a problem in front of me. A current loop having 2 circular arcs. So you've got 2 circular arcs, you've got a diagram, you can see that, and the current which is given is 10 amperes, and we have to find the magnetic field at the point O. What will it be? Okay, what will it be close to? So we have to find an approximate answer. Cool. Now here, when I see this reference figure, I see that I can divide it into 4 parts. Okay. We have an arc PS here. From P to S, there is an arc, right, like this, which carries the current like this. And then we have got a part PQ, which is a linear part. Then another arc QR, and then another linear part, which is RS. When I look at this figure, immediately after looking at this figure, I know what would be the contribution from the linear parts PQ and the part SR. What do you think will it be? Now, because this current carrying element PQ is linear and it is in the same line of the point where we want to find the magnetic field, the magnetic field contribution because of PQ will be 0, because the cross product of the DL element will be 0. That's the whole theory behind that, right? But you need to know that if there is a current carrying wire, and if you want to find the magnetic field at any point which is along that wire, right, any point here, there, or behind the wire, the magnetic field contribution because of that current carrying wire is always 0. Okay, so PQ and RS has absolutely no contribution, so they contribute to 0 magnetic field. Now I have got the arc QR and the arc PS. Let's talk about the arc QR. Now it's an arc, it's part of a circle, it's part of a loop. Do you know the magnetic field at the center of a loop which carries a current I and have a radius R? That magnetic field is equal to mu naught I upon 2R. Okay, and how do you find the direction? So for example, if I have a loop and if the current in the loop is like that, then I curl my fingers in the direction of the current. The thumb gives me the direction of the magnetic field. So in this case, the magnetic field is out of the plane of the screen. Okay, and if the current were like that, then the magnetic field is in the plane of the screen. All right. Now let me see for QR. Okay, but again, QR is not a whole circle. This formula works for whole circle. And what is the formula for an arc? All you have to do is multiply this formula with theta by 2 pi. Okay, so when theta becomes equal to 2 pi, the formula is mu naught I by 2R. When theta is equal to, say, just pi, you have half a circle, then the formula becomes mu naught I by 4R, and it would cover any arc. Okay, so let me do it for QR. What will be the magnetic field contribution because of that? That will be equal to mu naught times I here is 10 divided by 2 times, let me keep the R as 3 into 10 to the power of minus 2. Okay, that's very important. I have to convert each and everything in SI units. See, anytime you're dealing with a question of electromagnetism or any question in general in physics, but especially with electromagnetism, always keep your units in SI units, because there are a lot of constants which you know the value only in SI units. Okay, so don't take that risk. Into theta. Now theta is 45 degrees, but we have to always keep it in radians. So this will be by pi by 4, right, divided by 2 pi. Okay, that is the magnetic field contribution due to QR. But what about the direction? When I move my fingers like this from Q to R, the thumb gives me the direction, right, of the magnetic field which is out of the screen, right? So the direction is out of the screen and we represent that by a dot. So because of this QR, I have a magnetic field out of the screen like that. Okay, let me find that for PS. What is going to happen with PS? Okay, so that magnetic field, let me call it B2, will be equal to again mu naught times I, which is again 10 divided by 2 times r in this case is 2 plus 3, which is equal to 5, right? So 5 into 10 to the power of minus 2, I'm being careful, I'm converting everything in SI units, into theta is again pi by 4 because the angle is same for both the arcs, divided by 2 pi, okay? But what about the direction? Now when I look at P, from P to, the current is flowing from S to P, right? If the current is flowing from S to P, it means that the current is going like this. And if I move my fingers like that, I see that the thumb is showing me a direction which is inside the plane of the screen. It means that the magnetic field is like that, okay? So these two magnetic fields, because of these two parts, are not in the same direction. In fact, they're in exactly the opposite direction, okay? And because they're vectors, I can simply subtract them whenever there are two vectors which are opposite to each other, right? Then to find the resultant, all you have to do is subtract them. So that's what I'm going to do. I'm going to subtract these two quantities and let me see what I get. I can take a few things common here. Mu naught upon 2 into 10 to the power of minus 2 and pi by 4 by 2 pi will become 1 by 8, right? So it becomes 1 by 8 for both. So into 1 by 8, and inside I have got now 1 by 3 minus 1 by 5, okay? And what does this become? Mu naught is 4 pi into 10 to the power of minus 7 divided by 2 into 10 to the power of minus 2 into 1 by 8, and 1 by 3 minus 1 by 5 will be 2 by 15, right? 2 by 15. So when you do this calculation, and I just try to do it, you find that the answer comes close to pi by 3 into 10 to the power of minus 5, okay? And pi by 3 is a number very close to 1, and the question says that you have to find the answer which is closest to, and the closest answer which you have here is the option A. Let's see another problem from electromagnetism. So this problem says when the switch is closed, what will be the current I? Okay, the very first approach which people take to solve this problem is this, and this is the long approach, and I'm gonna just show you what people do. So for that, let me first name this this junction as D. Okay, so we have got A, we have got B, we have got C, we have got D. So the first thing I'm going to do is I'm going to move from A to D, okay, and I'll add all the potential differences. I know that when I move with the current, the potential, yes, it decreases, and when I move against the current, the potential increases, and across a resistor the potential changes by IR. Okay, so let me do that. So I've got at A, I've got 20, and I move across this, right? I get minus 2 times of I1. Okay, I have reached C now. I've moved across this and I've reached C. From C I'm going towards D, and I again find that I'm going with the current and I am crossing a resistor of 2 ohms. So it will be minus 2 times of I. That will give me the potential at the point D, which is equal to 0. So I've got one equation. Alright, let me do it taking this path from B to D. Okay, when I do that, B to D, what I find is at B the potential is 10, right? At B the potential is 10, and again I'm going with the current, so a negative minus 4 times of I2, alright, and then I have reached C, and from C I have to go to D, so that will be again minus 2 times of I, which is equal to again the potential at D, which is equal to 0. Okay, I have got 2 equations, but I have got 3 variables, so I need one more equation. Okay, if you want to find all the 3 variables, you need 3 equations, right? The third equation, for the third equation, I'm going to move from A to B. Okay, when I move from A to B, at A the potential is 20, minus I'm going with the current, so it is 2 times of I1. Then I have reached C. From C, when I move towards B, now I'm moving against the current. When I move against the current, it will be plus. So plus 4 times of I2 will give me the potential at B, which is equal to 10. So I have got 3 equations, 3 variables. I solve these 3 equations and I get the answer. That is one of the ways of doing it. Again, like it will again take you like a minute or so to solve these 3 equations and find the right answer. There is another way, an easier way to do this, which is, see, you know the potential of the point A, you know the potential of the point D, you know the potential of the point B, but you do not know the potential of point C. So one of the ways is to assume that it has some potential, say X, some variable. Okay, so there's another way of solving this problem. What I can say is, because I know that the current I1 is flowing between A to C, I can say 20 minus X, that is the difference in potential, divided by 2, right, should be equal to my I1, right? Similarly, the current flowing from B to C, for that I can say 10 minus X, the potential at B minus potential at C, divided by the resistor, which is equal to 4, the resistance should be equal to the current which is flowing there, which is equal to I2. And the same thing I can say for the branch C to D. For C to D, I can say that X, the potential at C minus potential at D, which is 0, divided by the resistance, which is 2, should be equal to the current, which is equal to I. So I've got 3 equations again, but see, all these 3 equations are in one variable X. And if I could somehow find a connection between I1, I2 and I, I'll be able to solve this. And what's that connection? The junction law, right? The Kirchhoff's junction law, which tells us that if I1 current is flowing from this end, if you have I1 coming from this end and I2 coming from this end, and this end you have got I, it means that I has to be equal to I1 plus I2, which when I do that, I get I is equal to X by 2. So X by 2 is equal to I1, I just found out is 20 minus X by 2, plus I2, which is 10 minus X by 4. So I get this one simple equation in one variable X, very simple to solve. You can just simply cut out these 2's, you get 2 here. A simple rearrangement will tell you the value of X is equal to 10 volts. But X is not what you wanted to find. You wanted to find I is equal to X by 2, which will be equal to 10 by 2, which is equal to 5 amperes. Let's look at another problem from electromagnetism. Now this problem has a parallel plate capacitor of side D and length and width equal to A, okay, and it is filled with a dielectric of dielectric constant K, and I can see that this dielectric constant, the width of this dielectric constant itself is changing within the capacitor, all right, and that makes this problem a relatively difficult problem because there will be a good number of steps involved to solve this problem. So if I were you, I would have attempted this problem in the end. I would have kept this problem at the end, because I can look at this problem I can see that there is going to be an integration involved, and I don't know how difficult or easy that's going to be. So I would have touched this problem in the end. But let us try it anyway, because now we have time, we are analyzing the paper. So what I'm going to do is, from this end over here, I'm going to consider a small, infinitesimally small element here of some length dx, okay, and I'm going to say that this length over here from bottom to this point, this length is some y, okay. Now you can see that this, as x varies, this y also varies. When x becomes equal to a, the y becomes equal to d, okay. Now is there a relationship between y and x? That's just actually easy to find out, because the way your dielectric is varying, it's the slope of it is constant. It's a straight line, right? This is a straight line over here. So what I can say, the slope of this dielectric is d by a, right, which is the height divided by the length, right, and that will be equal to, I can do the same for here, y by x, right, which will be equal to y by x, because y by x will give me the slope of the same line. So y becomes equals to d by a times x. So y is equal to d by a x. So I have a relationship between y and x. Great. When I look at this small junction that I have considered here, when I look at this part, I actually have two capacitors in here, or I can treat it as if I have two capacitors. One is this capacitor from here to here, which has this dielectric, and the other is this capacitor which doesn't have a dielectric, which is on the top. And these two capacitors are joined like this. This is the first capacitor and this is the other capacitor. The bottom one has this dielectric, the top one doesn't have the dielectric, right? And these two are joined in series. Alright, so I have two capacitors which are joined in series, and if I know the capacitance of each of those capacitors, I will be able to find the net capacitance. Alright, so let us find the capacitance of the bottom capacitor, this capacitor, let's call it C1. So let's find C1. So what will be C1 equal to? It is equal to K times epsilon naught times A divided by D, where K is the dielectric constant of that dielectric, epsilon naught is the permittivity of free space or vacuum, A is the area of the plate, and D is the gap between the two plates. Okay, so here what happens, if I write this, the dielectric constant is still K, epsilon naught is epsilon naught. What will be the area? Now this length, right, is equal to dx, right, and the width of this plate is A. So width multiplied by this length, A times dx, will give me the area. So A dx is the area divided by the gap. What is the gap in this case? So here these two bars or these two junctions are serving as the plates of that capacitor, right? So gap between them is equal to y. So this will be divided by y. So you get K epsilon naught A dx divided by y as the capacitance of the first capacitor. And let us find that of the second capacitor, the one on the top. Okay. In that case, the value of K is equal to 1 because there is no dielectric there. So 1 times epsilon naught. The value of A is still the same. The thickness is still dx and the area or the width is A. So area becomes A times of dx divided by the gap. The gap in this case, this whole length is equal to d, right? And this length is equal to y, right? So the gap becomes d minus y. So I have found C1 and C2, the two capacitors which I wanted to find. Now these two capacitors are in series, so I know that the capacitance is equal to C1 into C2 upon C1 plus C2, right? When capacitors are in series, this is the formula to find the net capacitance. That will be equal to C1 is K epsilon naught A dx by y, C2 is equal to epsilon naught A dx by d minus y whole divided by C1 is again K epsilon naught A dx by y plus epsilon naught A dx upon d minus y, right? This is the expression for the net capacitance. When you calculate this, you find that this comes equal to K epsilon naught A dx upon kd plus 1 minus K times y. So this is the net capacitance of this thin strip of capacitor that I have considered. Okay. Now you see where this is going. So you have just found the capacitance of this very thin strip. Now you'll have, actually to be honest, you shouldn't write it as C, actually we should write it as DC, because that's a very small capacitance of this very small capacitor. Now to find the capacitance of all the capacitors, right, I need to realize that the other capacitor, for example, this is one of your capacitors, the other capacitor is like this, the other capacitor is like this, and their ends are here. So this is the end of first capacitor, this is the end of second capacitor, this is the end of third capacitor, and they're joined like this. So all these capacitors which you will add through integration are actually in parallel with each other. And when capacitors are in parallel with each other, you can directly add their capacitances, which tells us that I can directly integrate this to find the net capacitance. So let's integrate this. So here I have the expression that I want to integrate, but when I want to integrate it, I have to be very careful about the limits on which I'm going to integrate this, right? So the limits of x, because x is the variable of integration here, dx we have got here, right? And x is varying from here to there, right? So the minimum value of x is 0 and the maximum value of x is a. So from 0 to a, my x varies. So this becomes equal to I can take K epsilon naught a as constant out, integration from 0 to a, dx I have on the top, kd I have on the bottom, plus 1 minus k, and the value of y is d by a times x. Okay, so I have written that, that's fine. Now let's move ahead. This becomes K epsilon naught a, integration from 0 to a. Now this a over here, right, and I don't like denominators below denominators, that doesn't look good. So what I'm going to do is I'm going to multiply and divide this thing by a. So when I multiply by a, I get an a square on the numerator, and when I divide by a, I get dx upon a k d plus 1 minus k times d times x. So remember, this is not dx, this is not the variable of integration dx, this is d times x. Okay, that is different from this dx. This is d times x. Now what do I get from there? So let's move ahead. This becomes k times of epsilon naught a square, integration from 0 to a. What is this expression? Okay, I can directly integrate this. So I remember that the integration of dx upon a plus b x, a general formula. What is the integration of that? The integration of that is ln a plus b x upon b. Okay, so whenever you have integration of dx upon a linear of x, the integration of that is ln of that linear divided by the coefficient of x. So here also we have a linear. This whole thing is a constant plus another constant. This whole thing is a constant times x. Okay, so this becomes, let me get rid of this. So this becomes times ln of a k d plus 1 minus k times dx. Okay, and whole divided by the coefficient of x, which is 1 minus k times d, and this thing runs from 0 to a. Okay, so that becomes equals to k epsilon naught a square upon 1 minus k times d. I can take out constant, and the value of this, when I plug in a, I get ln a k d plus 1 minus k times dA. The value of x is a, right? This whole thing minus ln of, when I plug in x is equal to 0, this whole terms becomes 0. I get ln of a k d. Okay, now I know this very famous rule for logarithms, that ln of a minus ln of b is equal to ln of a by b. So I'm going to write this here: k epsilon naught a square upon 1 minus k d, right, which is the constant which I had out of everything, times ln of a k d plus 1 minus k times of a d whole divided by a k d. Okay, ln a by ln b. So this is whole thing is my a, this whole thing is my b. Okay, all right, so I've gotten this. I've been very careful and I've gotten this far. Okay, a single mistake and you might get the wrong answer, or you might get stuck somewhere here. So this becomes equal to k epsilon naught a square upon 1 minus k times d, and this becomes ln of 1. When I divide this with this, I get 1 plus a and d gets cancelled, 1 minus k by k. Okay, I like that. I'm only left with k inside ln. This is equal to k epsilon naught a square upon 1 minus k times of d, right, times of ln 1 plus k plus 1 minus k will become 1 upon 1 by k. So ln of 1 by k is what is left here. Okay, and that becomes equal to k epsilon naught a square upon 1 minus k times of d, and I can take a negative out and this becomes ln k. Okay, and I can write that as k epsilon naught a square minus of 1 by k becomes k minus 1 times d times ln k. All right, and that is option number C. So you see that this question took a lot of time to solve. Okay, so be smart and always keep such questions for the end to solve, because you shouldn't aim for solving all the problems in JEE if you're being practical. Okay, you should solve all the easy questions first, and then whatever is you feel is easy, and then the medium level questions, and then the questions which might take a lot of time to solve. All right, so you should keep such kind of questions to the end. In this problem, I have a circular ring with a charge Q on it, uniformly distributed, and I'm supposed to find out the point where the electric field has the highest magnitude. Okay, but for that, first you need to know the expression for electric field in general due to a circular ring of charge. What do you think that is? That expression is kqx upon r square plus x square whole to the power of 3 by 2. You are encouraged to remember this expression, okay, if you are appearing for JEE. kqx upon r square plus x square whole to the power of 3 by 2, where x is the distance from the center of that ring at a point on its axis, and r is the radius, q is the charge on this ring, and this is the expression for the electric field. Now if you have a ring, imagine, okay, if you have a ring, at the center of the ring the electric field will be 0, because you take any element, there will be an opposite element creating an electric field in the opposite direction, right? So you have these pairs and the net electric field at the center will be 0. And a distance very far away from that ring, right, on its axis, electric field is again going to be 0. So the electric field is 0 at the center and the electric field is 0 at a point at infinity. It means that in between the electric field must rise and then again go back to 0, right? And I'm going to use this expression to find that. I want to find out where this expression has the maximum value, and to do that the method that we use is the method of calculus. That is, we differentiate this expression with respect to the variable on which it depends and then set it equal to 0 to find the local maxima or minima. So let's do that. So differential of E with respect to x is what I'm going to do. This becomes kq is a constant, comes out. I have got d by dx of x upon r square plus x square whole to the power of 3 by 2. Okay, so this is in the u by v form. Okay, d by dx of u by v. Okay, and what's the formula for that? The formula for that is v du minus u dv upon v square. Okay, v du minus u dv upon v square, that's the formula, right? So let me apply that. This becomes equal to kq times of v, which is r square plus x square whole to the power of 3 by 2 times differential of u, or differential of the numerator, which is just 1 because dx of x is 1, minus u, which is equal to x, and differential of r square plus x square whole to the power of 3 by 2 will be 3 by 2 times r square plus x square whole to the power of 3 by 2 minus 1, which is equal to 1 by 2, multiplied by the differentiation of stuff which is inside, that is the differentiation of r square plus x square, that becomes 0 plus 2x. Okay, alright, and on the denominator you have r square plus x square whole to the power of 3 by 2 my v squared. Okay, now let me write this down. This becomes kq r square plus x square whole to the power of 3 by 2 minus 3x square, right? This 2 gets cancelled, and this in x and x becomes x square, so that's correct, times r square plus x square whole to the power of 1 by 2 whole divided by the denominator which you have here. Now the thing is, I have to set this equal to 0, so the denominator doesn't matter. The denominator is anyway, I can like take it to the other end and make it equal to 0. For this to be 0, I'll have to equate this expression to this expression. When these two expressions will be equal, this whole thing is going to be 0. So r square plus x square whole to the power of 3 by 2 has to be equal to 3x square times r square plus x square whole to the power of 1 by 2. So r square plus x square whole to the power of 1 by 2, this whole thing over here, I am taking it on the other end. This becomes r square plus x square whole to the power of 3 by 2 minus 1 by 2, that is 1, right? Power 1 is equal to 3x square. Now this becomes r square is equal to 3x square minus x square is 2x square. Okay, or x is equal to plus or minus r by root of 2. Okay, to be totally sure, what you have to do is you have to take this expression, the differential that we found, and you have to differentiate it again to check that the double differential is negative, to make sure that it's a maxima. Okay, but I know that it is a maxima. I'm not going to do that again. In fact, you are advised to remember this result, that when you have a ring of charge, the point where the electric field peaks is at a distance r by root 2 from the center. Here I have gotten plus r by root 2 as well as minus r by root 2. What does that mean? It means that when you have this ring, right, and if I want to draw the electric field versus the position graph, if this is the electric field and this is the position, right, I'll get a graph like this. Okay, here it is, the electric field is 0, over here electric field is 0, then electric field peaks and then again goes to 0. The point where it peaks is the point r by root of 2. Okay, but on the other end, what happens, the electric field is in the opposite direction. Okay, so it goes like this and then it goes back to 0. So this point here, because this is my origin O, this here is plus r by root 2, this here is minus r by root 2. Okay, this is minus r by root 2, this is plus r by root 2, and that's why you have gotten two results. Okay, so the distance, if you just talk about the absolute value, the distance from the center where the electric field peaks is r by root 2. In this question, we have a PV graph, and we know that a gas goes from a state A to state B either via a state C or via state D. Okay, let's look at ACB. For ACB, the heat supplied to the system will be equal to the change in its internal energy plus the work done on the system. This is the standard thermodynamical equation, right? This is the first law of thermodynamics. Now, the problem is of the sign convention. We have said that a heat of 60 joule flows into the system. Is that plus 60 joule or minus 60 joule? To solve that, I have this small mnemonic that I have. Whenever this happens, it's positive. That is, whenever heat goes into the system, it's positive, and work is done by the system out of the system, it's positive. I know this. If I know this, I can solve a lot of problems, and sign convention will be really easy. So here the heat goes into the system, a heat of 60 joules. So this will be plus 60 equal to a change in internal energy we don't know. So it will be delta U ACB. Let's keep it like that. Plus the work done by the system is 30 joules. By the system is again positive. So it will be plus 30. So delta U ACB comes out to be 30 joules. Now the interesting thing is, because you reach from a state A to state B, the change in internal energy of the gas is going to be the same whether you go via C or via D, because change in internal energy is a state function. Okay, so this is still going to be 30 for the second case. Alright, but what is the heat supplied in the second case? So if the path ADB is used, work done by the system is 10 joules. So again, work done by the system is given as 10 joules. So this is given as 10, and heat is not known. So we have to find that. So delta Q ADB is what we have to find, and this is again 10 joules. I'm taking it positive because it is done, something is done by the system, right? So this is equal to 40 joules, and that's how you solve a problem of thermodynamics. Now let's look at another problem from mechanics. Now in this problem, I've got a spring and a block, and there's a constant force F acting on that block, and I'm supposed to find out the maximum speed that this block reaches. There's no friction. So when I look at this problem, the first thing that might pop up in my head is that a force is constant, and actually that is not true, because there's not just one force on this block, there are two forces. Because let's say this block moves by some amount, let's say x from its original position, the block comes over here somewhere, okay, moves by a distance x, then what happens? There is a force of the spring as well, right? And if it has moved by distance x, the spring is pulling it back by a force kx, and you have a forward constant force F. So overall the force is not constant, because kx of course depends on x, right? So the net force on this is F minus kx. Alright, and I have to find the speed. You know, anytime I get a question where I have to find the speed, I feel that somehow can I use the work energy theorem, because work energy theorem has this component of speed in it, because when you write the kinetic energy of half mv square, if that can work, especially when forces are involved, that's the best thing. So let me see that. So this is the force, and let me say that this block moves by a very little amount. From here to here it moves by, let's say, a very small amount dx. You know the drill, right? Let's say it moves by a very small amount dx. In that case, the work done, the small work done dw, will be equal to F minus kx times dx, right? Because the force and the displacement both are in the same direction, cos theta will be equal to 1. Cos 0 is 1. Now this is the work done, but this is the work done in moving that block, just displacement of dx, very little displacement, right? I want the total work done in moving that block from, let's say, its initial position 0, origin, wherever we want to choose it, wherever it was there from the beginning, to some x where I have brought it, the whole work done, the total work done. Now for that, what I have to do, I'll have to integrate this thing, right, on both the sides, and the limit of integration will be x is varying from initial 0 to some x. Cool. Now what will that become? So this becomes w is equal to integration of f dx would be fx minus integration of kx, k is a constant, integration of x is x square by 2, right? And this thing runs from 0 to x. When I plug in these values, I still get fx minus fx square by 2, sorry, not fkx square by 2, fx minus kx square by 2, right? This is the work done in moving this block from 0 to x. Now work done must be equal to the change in its kinetic energy, right? The work done by the net force or the net work done must be equal to the change in its kinetic energy. So this thing must also be equal to half mv square minus half m0 square, because initial velocity was 0. So let me equate this. So my w is actually equal to fx minus kx square by 2, and that guy will be equal to half mv square minus 0, right? Now from here I can get an expression for v becomes equal to 2fx minus kx square divided by m under root. Now I have an expression for v in terms of x, and I want to find the maximum speed of v. The maximum speed, all I have to do is integrate this expression with respect to x and see where this function peaks. So let me do that. Let me find dv by dx. That becomes equal to, what is the differentiation of something to the power of 1 by 2? This whole thing is to the power of 1 by 2. So anything to the power of 1 by 2 becomes 1 by 2, that thing to the power of 1 by 2 minus 1 by 2. So that's like, this is equal to 1 by 2 under root of 2fx minus kx square by m, right? The differentiation is still not done, right? Because then you have to go inside the function and differentiate that function also, right? This is called what do you call chain differentiation by chain rule, right? This is called chain rule, yeah. So let's do the chain rule. And the chain rule tells us go inside and differentiate. So when I differentiate 2fx by m, I get 2f by m. The whole thing gets multiplied, and minus k by m, differentiation of x square with respect to x is 2x, right? This is what I get. And I am not supposed to equate this whole thing to 0, right? When I equate this whole thing to 0, this thing is in the denominator cannot be 0, right? So numerator has to be 0, and this is the thing in the numerator. I have to set that to be equal to 0. Let me do that. This becomes 2f by m minus k by m times 2x equal to 0. All right, this becomes okay, I can simply just get rid of this 2 and this 2, it will go on the other side, this m and this m. I get the value of x equal to f by k. Okay, and now this is the position where the speed is maximum. Okay, you can cross check that by double differentiating this and finding out that double differential is negative, and I'm not going to do all that, and you also shouldn't do all that in exam, because if they're asking for maximum speed, it's understood that the derivative, wherever it goes 0, if there are not more than 1 point, it is going to be a maxima there. You don't have to actually go and check whether it's a maxima or minima, because let's say it's a minima, then what will you do? The question is wrong in that case, which is not going to happen, not all the time. So x is equal to f by k. Alright, now I have to go and plug this in this expression to get the v max. So v max is equal to under root of 2 times of f times of x is f by k, cool, minus k times of x is f by k whole squared divided by m. Okay, so I just plugged in place of this x, I have plugged f by k. Okay, and what do I get? I get under root of 2f square by k minus f square by k divided by m. So this becomes equal to f upon under root of mk. That's your v max, and that's how you solve a problem. Actually not, there's an easier way to solve this problem. And what's the easy way to solve this problem? The easy way to solve this problem is actually we can avoid all this integration and differentiation, and you can solve this problem directly if you just apply a little thinking into this. See, there's this block and there's this force which is pulling it, okay, and there's a constant force pulling it, and when the force is pulling it, that force F is doing some work on it. It means it is supplying some energy to it, and when a spring gets pulled, some energy gets stored in the spring in the form of its potential energy, elastic potential energy, right, configurational energy. That's equal to half kx square. So in one way I can say that, if F has done a work of Fx in moving that thing by x, because of a constant force I can directly write Fx, some amount of energy, that is half kx square, is getting used up in stretching that spring, and whatever is the remaining energy must be the energy which must be increasing its kinetic energy, right? So Fx minus half kx square is equal to half mv square is an expression you can arrive at without doing all this integration, right? This is the expression, right, which I arrived at here after doing the integration. So you can avoid that by, little logic. It will save you a lot of time. You can avoid the differentiation as well. Now once I've gotten this expression, I want to know where V becomes maximum. So here is a thing. When you have a block and when you have a constant force acting on a spring block system, all it does is it shifts the mean position of that system in the direction of that force. So the mean position of the system would get shifted here somewhat. And what is that somewhat? What is that x? To find that, what you do is you just, wherever the mean position is, at that mean position the force must be equal to the pull of the spring, right? Because at mean position the net force on this block must be 0, so x becomes equal to F by k. So x is equal to F by k is actually a position which is the new mean position of this. And I know when a block moves, right, its speed is maximum at its mean position. So directly I can say that at x equals to F by k, the speed will be maximum. I don't have to go through all this to arrive at this conclusion, okay, and I can directly plug it in and get the value of the maximum speed. Now in this problem there's a block and an incline, and there's a constant force of 3 Newton acting on the block, and there's another force P acting on the other end, and you have to tell what is the minimum value of P for this to not slide, for this to remain stationary where it is. What would be the minimum value that P would have, and there's friction, okay, 0.6 is the coefficient, and yeah, let's solve this problem. Now what would I do? I have to first recognize there's a third force acting in the system, which is the force of gravitation. The force of gravitation would act downwards, so from here you'd have 10 is the mass and G is also given as 10, so it is 100 Newton acting downwards on this, right? Now I can resolve this 100 Newton in two parts. I can say this here is 100, what is this? This angle will be 45, right? This is 45, so this will be 100 cos 45, that will be 100 sin 45. And the good thing is cos 45 is equal to sin 45 is equal to 1 by root 2. So this is 100 by root 2 newtons, and that is 100 by root 2 newtons. So you have 100 by root 2, 100 by root 2 separated out like that. Okay. Now there's 3 Newton, there's 100 by root 2 Newton, and there's P. Okay, 3 forces. There's actually one more force, and of course that's the force of friction. But now the problem is, the first thing, I think when I get this problem is, what will be the direction of the force of friction? Would it be acting downwards or would it be acting upwards? How would I figure that out? Now that depends on which direction this block is tending to move. If it is tending to go down, it is trying to go, the net force is downwards is more, then in that case the friction must be acting upwards. And if it is tending to go up, if P is so strong that it can pull it, then the friction must be acting downwards. What would be the case? So when I get this problem, I apply a little logic. I think that I have to find the minimum value of P, right? And P is trying to support this 100 by root 2 Newton and 3 Newton, right? P is trying to balance that. And I want to keep P as low as possible. So I want friction to be in favor of P, right? I want friction to be like a bro to P, and F plus P will take care of these things, and P will be as small as we would want it to. So I'm gonna take F to be acting upwards, and let's say if that comes out to be wrong, then we'll see. But that's the first. You have to make some assumptions, right? Now I have got F plus P must be equal to 3 plus 100 by root 2 for this block to not move. Okay, that's there. But friction force, is that kinetic friction or is it static friction? That's static friction, right? Because the thing is not moving. But static friction can only apply till a certain extent, right? There's a limit to static friction. After that limit, the static friction turns into kinetic friction, and in fact the thing would start moving. So that limit f of, or limit of f, right, or in fact limit of f is equal to something. The limit of f is equal to mu times of n, right? And in this case your mu is 0.6. and what is the normal reaction? Now here I had 100 by root 2 acting downwards, right? And there will be normal reaction acting normally, and that's why it's called normal, upwards. That normal reaction must be balancing the component of the gravity which is acting in that direction, right? In the perpendicular direction. So n must be equal to 100 by root 2. 100 by root 2. So right now we find that there are actually 5 forces. 3 Newton 100 by root 2. That's G, that's F, there's P, and there's normal. Okay. So this is the limit. So F must be within its limit. F must be less than or equal to F limiting. So I already have an expression for F, so I can substitute for F here. I can write F is 3 plus 100 by root 2 minus P. This is my F, must be less than or equal to 0.6 into 100 by root 2 is 60 by root 2. A little mathematical juggle here. I can take P on the other side. This becomes P greater than or equal to, because P comes that side. 60 by root 2 will come negative, so there will be 3 plus 40 by root 2. Okay, that's actually P greater than or equal to 3 plus 20 root 2, and that is 3 plus 20 root 2. Root 2 value is how much? 1.414. 1.414 into 20 will be 1.414 into 2 is 2.828 into the 0, so 28.28. So 28.28 is the number, plus 3 is 31.28, and none of the answers match. The closest is A, and A is the right option. So here I've got an L-shaped object, and that object is hanging from a thread, and it's tilted a little bit, and I have to find the angle of that tilt, right? The first thing is obviously a little bit tilted because, you know, of course it won't stand like this, right? It will tilt. But why does it tilt? It tilts because the force of gravity is applying a torque on it, right? And it will keep tilting until that torque becomes zero somehow. And unless that torque becomes zero, you won't have stability, right? We wouldn't have equilibrium, rotational equilibrium, right? Here this is an rotational equilibrium, and we have to find what is that angle. To find that, what I'm going to do is I'm going to find the net torque on this thing, and I'm going to equate it to 0. And the easiest way to do that, when I look at this problem, is to cut this L in 2 parts, right? I can consider this to be one of my system, this one part AB, okay, and then BC to be the other system, right? So when I take AB and BC there, because they are of the same length, I can say that they have the same mass also, M. Now on AB, exactly at the midpoint, right, because the center of mass would be at the midpoint, there is mg acting downwards, and here there's another mg acting in the midpoint of BC, downward mg. These two mg's provide a downward force of 2 mg, which must be balanced by the tension on this thread, which we are not very bothered about. Now let's see. Now what? Now let me do one thing. Let me find a torque about any point. Let me find it about this point A, the point over here, okay, and let me equate that to 0. So let's do that. So mg can be resolved into 2 components. If this angle is theta, this angle will also be theta, and I can say that this here will be mg cos theta, and this here will be mg sin theta. Okay, now mg cos theta is in the line that passes through that point about which we're trying to find torque, right? Mg cos theta is like this, right? So it will not provide any torque. The torque will only be provided by mg sin theta. And how much will that be? There will be mg sin theta, the force, times the perpendicular distance. So what's the perpendicular distance here? From here to here, the perpendicular distance is L by 2. So mg sin theta times L by 2 is the torque. And in which sense is mg sin theta trying to rotate this? it is trying to rotate this in this sense, that is counterclockwise. So this is counterclockwise. Okay, now let's go to the other part. You have BC, you have mg again acting downwards. Let me resolve that. So if I resolve this, I get two components here and here, parallel and perpendicular to that rod. This will be parallel to this, right? This will be parallel to this because this is perpendicular and this is also perpendicular, and if this angle is theta, then this angle is going to be theta. This will be mg cos theta, and here we'll have mg sin theta. Now in this case, both mg cos theta and mg sin theta will contribute to the torque, because none of them is passing through that point where I want to find the torque. So let me find the torque because of mg cos theta. Now mg cos theta is here, so let me write down mg cos theta, and what is the arm? The perpendicular distance from that point is this, right? This is 90 degree, this is 90 degree, this is 90 degree, so this will also be 90 degree of course, and this is L by 2, so this will also be L by 2, so the arm is L by 2. Now I also need to know in which direction mg cos theta is trying to rotate this thing. So it is this way, right? So it is trying to rotate it in clockwise direction, clockwise. Okay, now let's go with the other one, our mg sin theta. Now mg sin theta is acting like this, right? And if I want to find, so mg sin theta is my force. Now if I want to find the perpendicular distance, I just have to draw a line like this, mg sin theta. The perpendicular distance is this length, right, which we already know is L. So mg sin theta times L is the torque because of mg sin theta, and mg sin theta is trying to rotate it this way, which is counterclockwise. Okay, so because the net torque is 0, all the clockwise torques must be equal to all the counterclockwise torques. So mg sin theta L by 2 counterclockwise plus mg sin theta L, another counterclockwise, must be equal to mg cos theta times L by 2. All right. Okay, so mg goes away, L goes away. I get okay, 3L sin theta, 3L by 2 sin theta is equal to, sorry, L has gone away, so 3 by 2 sin theta is equal to cos theta by 2. So this 2 gets cancelled. Sin theta upon cos theta comes out to be 1 by 3, or tan of theta is equal to 1 by 3, which is option number B. So B is the right option. In this problem, you are given a particular configuration of a rod, a conducting rod. You are told that the temperature difference between A and B is 120 degrees. And what would be the temperature difference between P and Q? Okay. Now what will happen, because of this temperature difference, there would be a heat current that will flow, right? And when heat current flows, we have a simple relation, which is delta T is equal to I times R, okay, where delta T is the difference in temperature, R is the thermal resistance, and I here is the heat current. Okay, now in this case we'll first have to find what is the equivalent thermal resistance. Okay, so thermal resistance actually is equal to L upon Ka, where L is the length of that rod, A is the cross sectional area, and K is a coefficient, a thermal coefficient, right, of conductivity. Now here all these rods that we have here, they all have the same cross-sectional area, and that's a good thing. So A, I don't have to worry about, but you can see that different parts of the rod have different lengths. Okay, so let me see what will be the resistances in different parts. So from A to P, the length is L by 2, so I can say the resistance will be equal to R by 2, right, because R is L upon K. I'm defining it like that. So from A to P, the resistance is R by 2. Now from P to let's call it X. Okay, from P to X, the resistance will be R by 4. From here to here, it will be R again, because the length here is again L, and from here to here it will be R by 4. From here to here it will be R again. From here to here it will be R by 2. Okay, so these will be the thermal resistances. The way you solve a problem of thermal physics, especially a conduction problem, a problem of heat transfer, is the same way you solve the problem in case of electric current, right? So all you have to do is find the thermal resistances and then find whether they are in series and parallel, and find the equivalent resistances and find the net current flowing, and then using that you can deduce a lot of other things. So what I've done here is I have created an equivalent circuit that looks like this. Okay, now this resistance I've just said is R by 2. This is equivalent to this. This here is R. This again here is R by 2. This is R by 4 and R by 4. Okay, now let the thing begin. Now this R by 4, R and R by 4, they are all in series. So R by 4 plus R by 4 will give me 3R by 2. So this whole thing is 3R by 2. Now this 3R by 2 and this R are in parallel. So 3R by 2 and R in parallel means 3R by 2 into R upon 3R by 2 plus R. When two resistances are in parallel, this is the formula which you use. AB upon A plus B, or R1, R2 upon R1 plus R2 gives you the equivalent resistance. So this becomes 3R by 2 square upon 5R by 2 equal to 3 by 5R, right? So the resistance of this whole lot, right, is 3R by 2, or I can write it over here also. This whole thing has a resistance of 3R by 5, not 3R by 2, 3R by 5. Okay, now this 3R by 5 is in parallel with is in series with R by 2 and R by 2. So this becomes 3R by 5 plus R by 2 plus R by 2 is plus R. So that becomes 8R by 5. So 8R by 5 is the total resistance of all these resistances. See how quickly you can solve this problem if you know this small concept. So 8R by 5 is the total resistance, and the temperature difference is 120. So I'm going to use this formula. 120 is equal to the heat current times the resistance, which is 8R by 5. So heat current I comes out to be 120 into 5 by 8R. That is 2 times 4, 30 times 2, 15 times 15, 5 times is 75 by R. So 75 by R is the heat current. Alright, but that's not what I have to find. I have to find the temperature difference between P and Q. So for that I'm going to be a little smart, and I'm going to say that I know the equivalent resistance between P and Q. Between P and Q, that is these whole things, these all resistances combined, 1, 2, 3 and this 4, 1, 2, 3 and this 4 have an equivalent resistance of how much? 3R by 5. I had just found it out, 3R by 5. And how much is the total current flowing through them? The total current flowing through them is R 75 by R. So 75 by R goes from this end, comes out from this end, 75 by R. So the whole thing 75 by R is going. So I is equal to 75. So for that PQ, just for the PQ, I can say I is equal to 75 by R, and the equivalent resistance between PQ is equal to 3R by 5, right? So what will be the temperature difference? So delta T between PQ will be IR, that is 75 by R times 3R by 5, and that is 515, that is equal to 45 degrees Celsius. Okay, that is the temperature difference between junction P and junction Q. So that will be the right option. In this problem, we have two coherent sources, and it is told to us that the ratio of the maximum to the minimum intensity is 16. What is the ratio of actual intensities? Okay, so if let's say the intensity of these two sources are I1 and I2, okay, when these are the two intensities, when these two waves from these two sources, when they superimpose on each other, when they interfere, they are going to interfere constructively at some points, destructively at some points, and all other points they will be like neither constructive nor destructive, somewhere in between, right? So what I'm going to do here is I'm going to write the maximum intensity, okay, and that is root I1 plus root I2 the whole square, and this is a formula. It wouldn't hurt for you to remember, because you can't always go and derive. This comes from I is equal to I1 plus I2 plus 2 root I1 I2 cos theta. You put cos theta is equal to 1, so you get this formula. When you could put cos theta is equal to minus 1, you get the formula for I minimum. But you know, you can just use the faculty of your memory once in a while, because it's just easier. If a guy remembers it, he'll take less time, because optimizing time is also one of the most important thing in JEE, right? It's not just how smart you are. I mean, actually it is about how smart. It's not just about how deeply you know the subject. So now the ratio of these two things are given as 16. So I can say root over I1 plus root over I2 whole squared divided by root over I1 minus root over I2 whole squared is equal to 16. So this becomes root over I1 plus root over I2 upon root over I1 minus root over I2 is equal to, I'm taking square root on both sides, this becomes equal to 4, and that becomes equal to, I'm going to divide the numerator and denominator by root over I1. So it will become 1 plus root over I2 by I1 upon 1 minus root over I2 by I1 equal to 4. Okay. Now what can I do here is I can take this whole thing on the other side and I can write 1 plus root over I2 by I1 is equal to 4 minus 4 times of root over I2 by I1. So this becomes 3 equal to 5 root over I2 by I1, and 3 by 5 whole square will become, I took 5 here and squared, I2 by I1. That makes I2 by I1 equals to 9 by 25, and that's the ratio of actual intensities, 9:25, or in the options you have 25:9, so that's also cool, it could be anything. So 25:9 is the right answer, so B is the right option for this problem.
For more videos and live lectures on the JEE, click on the subscribe button now.